Hello friends, today we will discuss the synchronizing torque and synchronizing power in a synchronous generator. Let's start from this figure. We know that electrical power delivered by the generator is equal to EV upon XS sine delta, where E is the induced EMF of the generator, V is the system or grid voltage, XS is the net reactance between both of them, and then delta is the angular deviation between E and V. So if I will plot this equation in delta and P plane, I will get a sinusoidal curve like this. Now let me explain what is load angle. Load angle, one definition I have explained just now, it is angular deviation between E and V. The other definition is, it is the angular displacement between stator magnetic axis and rotor axis. Here I have shown. Suppose this one is stator magnetic axis which rotates at synchronous speed and this speed is constant. This is the rotor axis. It depends upon the speed of the rotor. We have the control of this axis, we doesn't have the control of stator magnet axis. So whenever we want to change the load, we have to increase the speed of the rotor so that this angular displacement will increase, so that the load angle will be increased from delta 1 to delta 2. And if my load angle increases, the sine delta will increase and the net electrical power will increase. So this is the way how the load is increased in the generator. So let me derive the synchronizing torque from here. Suppose at this point number 1, my load angle was delta 1, electrical power was PE1 and mechanical input at generator was PM1. So if I will divide this PM1 by omega angular speed and PE by omega angular speed, I will get TM1 and TE1. So TM1 is equal to TE1. So there is no acceleration. Okay. For acceleration, the condition is that the Tm should be greater than Te. If this Tm becomes greater than Te, the acceleration torque will become positive and there will be acceleration in the rotor. So at this point, Tm1 and Te1 both are equal. You can see I have drawn a line. This is Pm1, this is Pe1. So the Tm1 obtained and the Te1 obtained both are equal. So there is no acceleration, it is a steady state condition. Suppose suddenly the governor valve is opened in such a way that the PM1 is raised to a value of PM2. Okay. But the electrical output is still PE1. So from PM2, the torque we get is TM2, but the electrical output is TE1. So here the TM2 becomes greater than TE1. So this is a clear case of acceleration. So the rotor will accelerate, and as we know from this figure, the speed of the stator magnetic wheel is constant and now the rotor is accelerating. So the angular displacement will increase, and when the angular displacement will increase, the electrical power will increase. Now the electrical power will come from PE1 to PE2. And this change in electrical power is known as synchronizing power, right? So I can define synchronizing power as PE2 minus PE1. The change in active energy of the generator to bring the generator into its steady state. Okay. So earlier it was in steady state, but suddenly when steam is increased, it lost its steady state condition. So the extra power required to bring it into the steady state condition, it is called as synchronizing power. So we can derive this synchronizing power very easily. How we will derive? I will explain here. I have shown. We know that P is equal to EV by X sine delta. So if I will take the derivative of P with respect to delta and I will multiply this whole derivative with the change in load angle, I will get the change in power, which is synchronizing power. So what is derivative of EV by X sine delta? It is EV by X cos delta. This EV by cos delta I am getting in watt per radian. Okay. If I want to convert this radian into degree, I have to multiply this term with pi by 180. Okay, to convert it into electrical degree. And if I want to convert this watt per electrical degree into mechanical degree, I have to multiply pi by 180 with one more term known as pole pairs, the number of pole pairs. Okay, so this, let's forget about this too, and let's consider that we are talking in terms of watt per radian, right? So this is the derivative EV by X cos delta. This is also known as the synchronizing coefficient, power coefficient. Here you can see more the load angle will be there. If load angle advancement will be more, the cos delta term will be less. Okay. So we are going away from the synchronism. So that's why this is nothing but the rigidity between stator and rotor, the locking between stator and rotor, this coefficient. And when this coefficient is multiplied with the change in angle, the net term is known as synchronizing power. So EV by X cos delta multiplied by delta 2 minus delta 1 will become the synchronizing power. And when this synchronizing power is divided with omega s, means the angular speed, we are getting the synchronizing torque. Right? So I hope you are clear with the derivation of synchronizing torque now. And the synchronizing torque is shown here. The net change in torque, the extra torque gained by the generator to bring its output from PE1 to PE2 is known as synchronizing torque. Thank you and catch you in the next video.